2 slides, but if you listen carefully, you'll get the answer right and you get free donut. All right, so first we're going to cover MAC addresses. MAC addresses are given to your computer through 1 or 2 ways, locally and universally. This is defined by the UL bit, which is given in the first octet of your MAC address. So let's go to how you get the locally administered address. Your universally given address is given to your computer by its network card or NIC card, which is given according to the manufacturer. So in your MAC address, if you look carefully, you can actually see exactly who manufactured it through actually looking at the bits. Then you have the universally, that's the universal or burned in. Then you have locally. Locally can override this entirely. So if you're a network administrator and you want all the computers or devices on your network to have a certain range of MAC addresses, you can do that and it will override the universal MAC address that is given in firmware or the read-only memory and a network card. All right, now also in the UL bit, there's also where it can it'll show whether or not if it's multicast or unicast. If it's multicast, it'll be set to a 1, which allows it'll to receive only once frame for everything on the network. And there's unicast, which means that every device on the network will receive that packet, but only the one with the right MAC address will actually interpret it and start decoding. So let's go to the OSI model. The OSI model is very important. It has all the layers of network that you can possibly go into. The MAC address is on layer 2, which is data link, which also goes into local link, which we're coming up to right now. So, sorry, it's supposed to be a logical link control. Logical link control determines whether or not you have multiplexing, flow control, and also error control in your network. And modern networks, however, the flow control has been offloaded to things like TCP protocols, which is in the transport layer protocols. There's also, the error control is also handled by that same mechanism. I mean, it's not just TCP, it can be UDP, and it can be other forms and variants. But today, multiplexing is the only thing that logical link control does. And multiplexing is essentially saying, on a network, you can have several devices connected with several different MAC addresses and use different types of communication protocols. And they'll all interact and work around one another dynamically to make sure everything gets proper connection. All right, question time. What do the first 3 octets in the MAC address represent as a universally administered address? Right. It's actually close.
That doesn't come at the front.
What?
I hate front.
They're from Krispy Kreme, but I got them there too.
Fresh baked, microwave. There you go, that worked.
Also, the universally administered address is also known as OUI. That's why it's there, it's a hint. All right, next is frames. It's a data packet in layer 2 of the OSI, so it's in your data link. Essentially what a frame does is it's a number of bits that are transmitted, and let me actually make sure I'm talking about everything. Yep. There's a certain set of bits that are transmitted, and they start with a header. And basically a frame, it's a header bit that says, okay, everything in the next 8 bits is going to be 1 frame. And if you are a computer on the network, it'll wait until it sees that first header to start reading everything behind it in packets that are in that 8-bit frame. So that's where frame synchronization comes in, where it'll actually make sure that your computer is reading everything in order. So when it starts to decode that frame, everything will be properly where it's supposed to be. We actually do a little diagram. Frame synchronization works like this. You have Has anyone got a Sharpie? Something right now?
No, you.
Oh, awesome. Oh, well, they want to know it forever, right? Stray rates.
Never get
It's
it
okay.
wrong.
Stray rates. Alright, so frame synchronization works like this. So think of this as frame sync, and you have frame sync ID, right? So these are two individual headers, and then everything else is the 8 bits. So you got packet 1, packet 2, 3, packet 4. Sorry, that's not B, that's B. 4, packet 5, packet 6, and all the way up to 8. And what it'll do is, without frame synchronization, it'll get to packet 8, and it'll start putting the next header. It'll have FSI still there, which is saying the next set of the next frame stream with everything contained in it. So what frame synchronization does is actually gives you a chart of all the frames that you've received instead of it being jumbled together. So it'll say, okay, now this is frame 1, so this is your major frame. Well, it goes down to the next frame, and it says, okay, starting with this header, this is everything in this frame, and so on and so forth. And that's what frame synchronization does. There's different types of protocols it uses to organize them, but essentially that's the general concept. And there's different types of things that can use that, which is PPP, point-to-point protocol, V42, modern frames, Ethernet frames, different types of ways you can do it. All right, what does frame sync do? Does anybody know? Really? Okay.
No one wants any donuts.
Does anyone know what frame synchronization does?
It tells you when to start reading all the different packets and when they start and end.
Yeah, within a frame, yeah.
Yeah.
So yeah, it's not.
I don't like potato.
Oh, yeah.
Seriously?
No, I only like Dunkin' Donuts.
So, okay, who just wants a free donut? You raise your hand. Yeah, he gets it. The guy on the back. Alright, so next we're going to have a video which basically goes into a simple sliding windows protocol, and we'll go back in. This will help give you a general overview of what sliding protocols actually do through the rest of the presentation. It's just to help you get the concepts. So, if I want to play the video, is it just linked?
Yeah.
Okay. Okay.
Yeah, that's
All right, here we go. Yes.